Hey everybody, hope you're having a good Wednesday. We're back for another live cast, and we've got some cold weather here, and one of the things I was doing here was chasing out a rat here at the ranch here. One thing I noticed, let me show you this real quick. You see these rat traps? You know, I really don't like using these, but it's hard getting rid of. You know, if you have a stray rat running around, those things are destructive. This is a chemical called brodifacoum, and look how much the price is, $7.99. Well, apparently the EPA has ordered the manufacturers to get rid of these. Check out what the prices are out on Amazon. It has gone up quite a bit. There's a shortage, and these things are in high demand. I just now noticed that. Fortunately, I think I got rid of the rat. No more problems. But last night's webcast, at one point you could hear one of those scratching around, but it's gone now. So today, instead of worrying about the rat, we're worrying about cold weather. These were the high temperatures today across the U.S. You can see we dropped down to 40 to 45 here in Texas. Up to the north, that's where the cold air is. Kansas with 20s, and the Dakotas have single digits and below zero. So basically we've got cold air advection in the North Plains and the cold front all the way down in the Gulf. And 70s and 80s, those are only found in Florida today. The temperature anomaly chart looks like this here. This is valid for 18Z. And you can see that it's much colder than normal, and especially in the Great Basin area. That's a good indication that we've had a lot of cold air development west of the Rockies in the Great Basin area. And that's an area that tends to trap cold air, and you can get some pretty strong cold air masses forming in that area. That's where a lot of cold air outbreaks in Arizona and New Mexico get started, is due to these cold air masses getting started in the Great Basin area. 500 millibar chart. This is up at 18,000 feet. So what kind of flow do we have? Yep, we've got northwesterly flow yet again. You have to keep in mind that the broad scale flow is looking like this. So these are the large scale troughs. So the long wave trough is located in the eastern U.S., and the long wave ridge is located in the eastern Pacific. So kind of like that. So the long wave ridge axis would be about like that. The long wave trough axis would be about like that. And at smaller scales, that's where we pick up the smaller scale waves. Let me try that again. Okay, trough, ridge, probably a weak trough embedded in this anticyclonic ridge. Probably another long wave ridge or short wave ridge located right in there. Trough, ridge, so you see how that goes. And like I mentioned yesterday, there's probably even smaller scale troughs and ridges embedded in that. So quite a challenge there. But we can see that the strongest flow here at 500 millibars, located from northern Nevada through Kansas and out to the Ohio River Valley area. So kind of like that. So 80 to 90 knots flow aloft. And there's a little bit of a hint of maybe a subtropical jet in the Big Bend area, New Mexico. So we can check that out and see if that's showing up on the 250 millibar chart. And yeah, looks like possibly something like that. You can see down there in Chihuahua and El Paso, 115 knots here, 115 at Midland. So that would be our subtropical jet, and another indicator of that is the anticyclonic flow, which is a distinguishing characteristic of subtropical jets. So that's going down like that. Obviously no baroclinicity in Florida and the Bahamas, so that's another indicator right there. Now we were talking about the 500 millibar chart, and let me bring that back up. We were talking about how embedded in this you could see probably some very small scale waves. We can kind of see that on the AWIPS charts. Let me bring this up a little bit, maybe to 24 hours in the future. Okay. So this is an example here where you see larger scale troughs. This one from the Great Lakes area to Nevada or to Nebraska. And at a smaller scale, you can see what may be noise. But there could be very small. The model is basically picking out very small mesoscale waves in here. So maybe a weak trough right there, maybe some ridging here where we have the lighter shades. And of course the radiosondes don't detect that very well, so there's a little bit of ambiguity at the smaller scales, what's going on. And as you can tell, a lot of this noisy area kind of gets started over the Rockies. So there's a little bit of terrain effect that's probably involved in this, along with the more the lower static stability in this area here on this side of the jet. Radar right now, let's see, do we have radar up? Looks like this frame of AWIPS went to sleep, but we can get that on the SPC experimental page. I'll just bring that up real quick. And I think we're looking at a pretty quiet pattern across the U.S. right now, except in California. We've got some showers going out in that area. So new system coming on shore, looking like this, and basically in the Sacramento area, Lake Tahoe, and the Yosemite area. What do the soundings look like in that area? Let's check that out real quick, and we'll bring up the Oakland sounding. We don't look at that in the western U.S. very much. This would be kind of a good educational opportunity here. This is the 0Z sounding. Okay, it's still got Fort Worth here. Let's click that again. And here we go. Here's the Oakland sounding. This is in the San Francisco area, just basically across the bay. So we have what's basically a lapse rate that is moist adiabatic. And it's humid too. So we might see kind of a showery, cloudy appearance with this. If we get a little parcel ascent, we might get a little bit of shallow cape in this area. So that's probably to a certain extent what's going on. Also what looks like a frontal inversion, maybe right in here, or that could be an inversion from air coming off the Pacific, one of the two. You can see a fairly high tropopause here. This is up at about 40,000 feet. Let's see what the soundings look like a little bit further in California. I bet Ron is loving this. We don't focus on that part of the country too much. San Diego sounding looking like this, and you can see a little bit more stability in the mid-levels, and this is partly due to the influence of the subtropical high down in the lower latitudes. So there's a little bit of subsidence going on in this area right here. High tropopause due to the warm nature of that air mass. And below that inversion, we can see kind of like the effects of maybe some polar air. Maybe some older polar air at these levels here from about 4,000 up to about 10,000. And this could be some fresher polar air down at this level in the lowest couple thousand associated with this northerly flow here. And where are the cloud layers? There's going to be one here. So that's basically from about 5,000 up to 10,000 feet. Kind of clear above that. And then looks like some cirrus above that at about 30,000 feet. So this is kind of how we go about interpreting soundings in an area we're kind of unfamiliar with. And I'll pull up Las Vegas real quick. And the big mistake that I've made here is I did not go over the surface data yet. That doesn't mean we can't kind of build up a general idea what's going on. Here we have an inverted V picture here, so this indicates dry air near the ground and moist air above that. So it looks like also some mid-level clouds up at about 5,000 to 10,000 feet. Probably a lot of stratocumulus, and above that could be a few layers of altocumulus. High tropopause, so kind of a warm air mass up there too. So let's do that thermal analysis real quick, and those of you who have been with the program a while, you probably know how I do this. I go in and look at the NAM panel, and I pick out the 1,000 through 500 millibar thickness. I'll bring up the chart that has the precipitation, and we'll get started on that. Still don't have that, so I'm going to go to the 18Z cycle here. Okay, here we go. This gives us the precip, so a little bit more interesting to look at. Okay, so thickness ribbons basically through the central U.S. out to the central Atlantic coast, and another one through northern California and out into the Pacific right there. So our fronts are basically going to be south of that. So I'll probably put a front like that just off the Atlantic coast, arcing back into Texas, maybe into West Texas like that. A little bit indeterminate here in the southwestern U.S., but it looks like part of the front yeah, it's almost certainly coming back through western Colorado like that and connecting back into the Nevada system, something like that. We pick up a little bit tighter gradient in here, so I'm thinking maybe something like that for the front. And when I say this is indeterminate, I'm saying that maybe we had an old polar front maybe get kind of stuck in the mountains here. Maybe a little bit of trapped cold air somewhere in there, kind of reducing the values in there a little bit, and maybe an old washed out front, maybe something like that in old Mexico. Let me take a quick drink here and promise you this isn't Jack Daniels or anything like that. This is a LaCroix seltzer here. Bulk of the cold air mass over the Hudson Bay and over Manitoba. And let's check that out. So I'm kind of building your expertise here with soundings by looking at radically different air masses. So here at Manitoba, you can see the skew T is way over on the left. And this is also hinting at some subsidence in the mid-levels. So the column was probably originally kind of like that with a low tropopause, and something has warmed the column. So we're probably getting a little bit of upper level ridging work into that area. Does the NAM show that? Yeah, it actually does. Go up to the north, there's a bit of ridging right here. And that's probably been working on that area part of today. Let me back this up a little bit further. Yeah, there we go. Okay, yeah, this corresponds to right now. I was a little bit off right there. So our radiosun location is right there, and upstream of there, yeah, there's a lot of ridging in there, so there you go. And the core of the mid-scale trough, basically the subsynoptic trough, I guess if you want to call it that, kind of in that area, and that corresponds to the core of the coldest air. So anyway, let me shift our surface analysis up there and maybe we can see that. Yeah, temperatures right around 0 to 5 degrees above, kind of in this area here. And ironically, as you go further north into the northern prairies, rises up to 20s, and 28 right here in the Northwest Territories. So it gets a little bit warmer as you go north. We haven't looked at satellite data in a while. Maybe I can pull up a quick frame here and we can check that out. Obviously it's dark right now, so we can't look at visible imagery, but we can pull up a little bit of infrared imagery. Now, as you're probably aware, this time of year infrared imagery can be a bit tricky because there's a lot of cold air. And that kind of cold air is what we get with mid and high clouds, and that's also the same temperature as the ground, so those can kind of interfere with one another. Bring up the enhancement here, and here's a good example. In the northern plains, kind of looks cloudy in this area, doesn't it? Well, some of this is probably the cold ground. If we look at the temperature scale, very light blue, that corresponds to temperatures of about minus 26, minus 28 Celsius. Minus 26, minus 28, that's going to be maybe about minus 0 to minus 5. That's pretty close to the ground temperatures in that area. And I guess what we're doing is we're picking up the very tops of these clouds right here. And then things are a little bit more clear when you get out to British Columbia, and when we get out here, yeah, see, this is probably a little bit more of the clear air. So things get a little bit fuzzy. Here's the clouds in this area, and clear in this area. So that can be kind of tricky when you're looking at cloud cover. And out in the Ontario, Quebec area, looks like a baroclinic system in this area, and you can see the dry slot working up that way. And then in the Central Plains, going a little bit further south, let's see what kind of patterns we got. Well, obviously we've got some sort of trough probably moving through this area, maybe a little bit of lee side cirrus. And then further out in California, you can see some of the mid-level cloud associated with the next system coming in. Okay, I think that's about all I got for the current picture. So I think we're ready to head into the forecast. All right, better take another drink here. And I'll say hello to everybody in chat and see what people are talking about. Audio sounds good. Kevin, east of Chattanooga, wondering if you're going to get snow this weekend. We'll take a look at that when we run the charts. 2 to 3 inches in the North Georgia mountains this weekend. Yeah, it sounds like maybe a bit of a snowstorm in that area. Looking at about an inch of snow there in Atlanta. some complaints that they don't have winter weather preparation equipment, so not quite ready for the storms. And I-80 between Cheyenne and Laramie, Wyoming, is closed because of snow. Highway between Reno and Lake Tahoe also closed due to heavy snow. So, yeah, that's going to be basically in this area right here. Looking at I-80 basically between Salt Lake City and Sacramento. So, yeah, that's going to be in this area. And you can see up to the north, there's very strong pressure gradient in this area. So this is going to be a cold air advection area just north of I-80. And I-80 itself is, or actually the front is going to be kind of right in this area. Let's check out the surface data just real quick and see if we can kind of isolate that front. Let me get that centered right there. And what do we got out there? You can see we got southerly flow at Tonopah and Ely, Elko showing southerly winds. A little bit of north winds there at Las Vegas, which is kind of unusual. So this is suggestive of probably a little bit of warm air advection. And then the actual front that we're looking at is probably set up something like that. And we saw that there was some shallow cold air on the Oakland sounding. So this is probably all an area of cold air advection through Reno, through Sacramento, through Oakland, Redding, and just north of Elko. And east winds right here, I forgot, that's not Twin Falls, or I can't remember what that city name is. But that's suggestive of probably a little bit of cyclogenesis right in this area of northern Nevada. So that's how we would go about doing a frontal analysis in that area, and that's right there what I would go with. And as we know, you take the low center and follow the track of that. Just left of that track, that's going to correspond to your heavy snow area, something like that. So, yeah, north of Salt Lake City, far northern Nevada. Assuming the low goes that way, that's what I would be looking at for snowfall right there. And this also corresponds to your warm conveyor belt area. It's going to be up there on top of the frontal boundary. That's kind of where everything comes together. So back to the GFS. We'll go ahead and run that forward into tonight, and let me get that centered there. And yeah, let's go forward. Overnight hours, you can see that cold front sinking south through the Great Basin deserts. Looks like the front works down through the San Joaquin Valley, maybe around Fresno. And out in Texas and Nevada, or New Mexico, it's getting hung up on the mountains there. So not particularly a deep air mass. And this is really where I should go back and look at the sounding. Let's check out Amarillo. We'll bring that up, and not showing much of a cold air mass there, but what there is looks pretty shallow here. Let me bring up Dodge City. Okay, I think Amarillo was just south of the front. Let me check that out real quick. I may be a little bit screwed up on the frontal position. Amarillo looking like this. Okay, yeah, they've got south winds right there. So that's going to be south of the front. And then Dodge City, that's going to be behind the front. And we can see there's southeast winds and very strong frontal inversion right there. You can see the humidity. The moisture line follows the temperature. That's a classic frontal inversion right there. And that's going to be about 7,000 or 6,000 feet off the ground. And we'll tie that in with our picture of surface conditions and look at the front. Yes, so basically it looks like our front is something like this. And looks like our new blast of cold air working southward through Breckenridge, through Aspen. and down to the Colorado Springs area, and south winds in the Pueblo and Trinidad and Alamosa area. Okay, so that's kind of what's going on right there. We'll tie that back in with our GFS panel. And basically we're seeing the cold front pushing its way southward, and it looks like it is getting hung up in the mountains, higher terrain of New Mexico. And we have to consider that I-40 between Amarillo and Albuquerque, it rises to a height of 8,500 feet above sea level in this area right here around Klein's Corner. So that's quite a upward ascent the cold air would have to make to get into the Albuquerque area. And there's actually a mountain pass just east of town. But when that cold air breaks through, they get some very strong canyon winds east of Albuquerque, and those can really get gusting up to about 40, 50 miles an hour when that happens. Okay, for our webcast tomorrow, Thursday, going to see that front push southward and kind of build in. It's going to be in the Four Corners area through Las Vegas and pushing through the Los Angeles area. For the webcast on Friday, you can see some of that, most of what we have along the edge of this frontal boundary is kind of being lifted southeastward by an upper level system. Because we can see strong cyclogenesis right here in New Mexico and not much in Texas, but we see the precipitation area kind of shift eastward during the day, and there it is right there. So it looks like some sort of wave working its way eastward during the day on Friday and getting into the southeast U.S. on Saturday. So Saturday morning looking like this. Looks like probably some low pressure just above the surface in this area, getting a little bit of isentropic lift over the frontal surface in the Carolinas and North Carolina. And GFS going for some strong snow right there around the Asheville and eastern South Carolina area. We're going to see what the Canadian model shows for that. Sunday, just kind of high pressure and ridging across the Central Plains. The Pacific getting active once again. For Monday, more high pressure across the western or the central U.S. and getting warm air advection getting started right here. So basically we're getting a pattern kind of like this here. For Monday, warm front lifting northward, and looks like this high pressure moves mostly to the southeast. For Tuesday, yeah, there goes the system, and we just get the back end of that with the cold front moving southward, kind of a weak push of cold air, and we're back in the warm air advection pattern for Wednesday. So it looks pretty mild on Wednesday next week. Very strong southwester warm air advection from the southwest, and you can see that the Gulf is open, so we should see the moisture really increase in Texas, and things get a lot warmer around midweek. Thursday the 12th, it's like another push of cold air southward. Friday the 13th, like that. That's going to affect mostly the Midwest. And now we've got some action out on the West Coast for the weekend, for Saturday the 14th. Backdoor cold front for Texas over the weekend. And looks like that moderates when we get back into a warm air advection pattern. And now we're starting to get pretty far out as far as the models go. And that's probably about as far as I dare go, but definitely looks like continued northwesterly flow pattern for the central and eastern U.S., but no severe cold air outbreaks. And let's see what the Canadian model had for the southeastern U.S. Okay, so here we go. You can see a lot of upslope flow in the Clayton, Las Vegas, Santa Fe area of New Mexico. That pretty much is probably going to be along the leading edge of that wave. And then it comes out into the eastern U.S. here and diminishes here in New Mexico. And it looks like the Canadian model is going for most of the impact to be further south in Florida and Georgia. And you can see not much for North Carolina and Atlanta. And this is kind of significant because the Canadian model so far has been one of the most, it's been handling the systems probably better than the GFS. But still looks like going for a little bit of snow here in the Raleigh, Charlotte area, and some sleet closer to the coast around Wilmington and the Outer Banks of North Carolina. And I'm probably losing my voice here, so that's probably about all I got. We've done 33 minutes, and hope you learned a little bit there, and we'll be with you at the usual time tomorrow. So I appreciate you joining, and we'll hopefully see you then. If you have any comments or questions about the webcast, leave it on the video page, and I will definitely, I still need to get in there and take care of that. I'm sorry if I haven't answered your questions, but yeah, but please do that, and that's about all I got. We'll see you tomorrow. Thanks.